Alrighty, so before we get into experiments, we're going to talk about time and causation, because experiments are often the design method we use to reduce bias, and therefore we're able to say that something definitively causes something else. And when we're talking about causing something, we need to think about time in relation to the independent and dependent variable. So this is sort of a primer. So causation in the social science is the focus of explanatory research. So explanatory research is how do we explain what produces such a phenomenon? So we might be talking about crime. How do we explain what causes crime? What causes people to do crime? And so when we're talking about these findings and these research questions, we're thinking about it from a probabilistic frame. And so remember in last week's lectures about sampling and understanding findings within research, a lot of times we're talking about likelihood that something might happen. So if there are specific incidences and in which something doesn't happen, that doesn't mean that there's no statistical finding that we can generalize about. And so there are two models of explanation, which we talked about in the first week when we were talking about knowledge production. And so one is ideographic. It lists the many, perhaps unique considerations behind one action. So it's sort of focused on something smaller in particular, whereas nomothetic lists the most important and fewest considerations, variables that best explain general patterns of cause and effect. So this is very much a more economic approach for understanding things. Usually economists call their type of designs parsimonious, which means that it's the simplest explanation of X causes Y, right? And so that's usually what we're looking for when we're talking about causation and experimental designs. And remember, cause is something that we can say definitively, this has an effect on this. So there's necessary cause and then there's sufficient cause. So necessary cause represents a condition that must be present for the effect to occur. So an example is being charged is a necessary cause to be convicted. You can't be convicted unless you're charged. Sufficient cause represents a condition that if it is present will pretty much guarantee that the effect will occur. So pleading guilty is sufficient cause to being convicted. We know that if someone pleads guilty, there's not going to be any other intervention except for they're going to be convicted. So these are different types of causes. Necessary is something that is needed in order for something to be said to affect something else, and sufficient cause is something that sort of guarantees it. So you can necessary sort of has it in the definition within its title, whereas sufficient cause is something that can be guaranteed, is a word that I would think of when I see sufficient cause. And so this is a criteria for causality. So any relationship that satisfies all of these criteria is causal. So one, there has to be empirical relationship between two variables. So it has to be grounded in reality. We had to have set up a design where we saw something occurring. There has to be a temporal order. So the cause has to come before the effect. If the cause comes after the effect, then we're getting our time ordering mixed up. And that's why time is important to think about. And there needs to be no alternative explanation, no spurious other variables affecting the initial relationship. So we need to make sure that we've controlled for all of those, and we'll talk about random assignment and how it helps us do that. And we need to account for anything that we're not necessarily thinking about. And you'll see the slide over and over again. So make sure to remember these three criteria for causality. So sometimes when we're dealing with causality, we need to be really important about how we're thinking logically. And so ecological fallacy is a danger of making assertions about individuals based on the examination of groups or aggregates. So an example would be if we just blatantly say that poor areas are what cause crime. And so this could be sort of a internal perpetuation where we're saying that, and then therefore people commit more crime. And so we need to be really careful about isolating the variables. And there's also individual fallacy. So using anecdotal evidence to make an argument. So if you like, anecdotal evidence can be very compelling. We often see like people writing about their stories and pushing for policy proposals, and that's all great and well. Sometimes it's nice to attach yourself to an individual, but we need to not be able, we can't really say that something caused something just because one individual experienced it. And then there's reductionism, failing to see the myriad of possible factors causing the situation being studied. So if we're designing our study where we know that there are other variables that might influence the dependent variable that we're interested in, say crime, if we're just considering one aspect of what causes crime and not being completely, and this is a word from the second week, exhaustive in defining all the realms of possibility that could cause crime, then we're being reductionist. And so I'm going to give you an example of an individual fallacy example. So lots of times we see in the newspaper and whatnot, NFL players getting into domestic violence incidences with their partners or families. And so a common then thought, conclusion, cause is that NFL players are more violent, that playing in the NFL causes violence. But when we're thinking about cause, we're often thinking about an effect. So the effect is playing in the NFL. And so we need a counter to that. We need a null hypothesis to that. And so not playing in the NFL would be another. But if we compare the general population of the NFL and their statistics on domestic violence to, let's say, the general population of men, then that's going to be like comparing apples to oranges, as they say. It's not an accurate comparison because we see that NFL players are 100% male, 67% Black, and young. So instead, we need to have a comparison that is proportionate, as we said in prior lectures, to what we're talking about. So if instead we compared NFL players to their demographics, in actuality, NFL players have an assault rate half the size of their comparable group population. So this is really an important example of individual fallacy, and also the need when we're trying to make causal claims that the NFL causes people to be more violent, that we have a sample that's similar looking, or we set up a specific design that reduces selection. And so when we're talking about selection, there's certain men that get selected to play football, right? They're likely more athletic than the general population of their same age bracket or race bracket. They're likely probably have like been playing football for a long time. And so there are all of these different components that actually influence going into the NFL. And we need to isolate those and find a group that's comparable. So we could randomly assign people to enroll in the NFL, and then that would be like a really strong causal claim, but that's not super ethical and that's controlling, and we just wouldn't necessarily do that in society. So we're going to be talking a lot about also quasi-experiments, which are when we can't do that randomization and reduce that selection that we talked about of other variables that make it more likely for you to join the NFL. So causation and time. So we need to control variables, other factors that might be influencing the dependent variable. And time may also be included in the sampling and analysis. And we also must consider the time order of events as well. And so causation and time are really intricately related, because when we're saying something about this causes X, we're inherently saying because the X causes Y, X comes before Y. That's an assumption that we're stating. So there's retrospective and then there's prospective research. And so this also is an element of time that we're talking about. And there are other elements of times and like how long we're observing things, if we're looking over time and whatnot. So retrospective is when we ask people to recall their past, and we're getting data from past things. And so this can be difficult, especially when we're dealing with trauma and people who are involved in the incarceration system. And so some people will do things like provide a calendar with like key events that happened in history prior. So that way, at least the person who's recalling these instances has some type of reference. And sometimes we're not asking people directly, but we have those secondary sources that we can look prior into. And sometimes the struggle with that is that they're filled out by people, and sometimes people produce inaccuracies in their reporting, so it can be difficult. Then there's prospective research, which is like a longitudinal study that follows subjects forward in time. So we'll talk more about quasi-experiments and get more into this and the many ways in which we do like panel studies where we follow people and check in with them at certain points in history, or cohort studies, and we'll get more into that. But the gist of it is longitudinal studies, there's a sense of time that we're looking at our observations over time. So a lot of research that you'll read where it's like, we found that graduate students are 30% more likely to have depression or something like that. So in studies like that, usually they're having those findings from a cross-section, one point in time. But then there's also options when we're doing research to do studies that actually put time into as a variable, and there's multiple observations throughout time. So this is the time to mention summarize. As I said, cross-sectional studies, which is a single point in time, we can think about visually as a snapshot. It's like an image, a picture. So we get a bunch of these observations at one point in time. Then there's trend studies, which are a series of snapshots in sequence over time. And so this allows us to see how time might influence or be an independent variable on a dependent variable. So we could see how crime reduces over time, and that is a historical trend that has occurred. And we would understand that through a trend study. And so trend studies we can think of as a slideshow of a bunch of images that are happen like, okay, once a quarter, we're going to say what the crime rate is, and then we're going to put time as an independent variable and see how time influences crime. Then there's the panel study, which is giving information about individual observations over time. And so this is when we sort of set up time into our design. So rather than looking backwards through a trend study and seeing snapshots over a period of time, instead we're observing people in the design that we've set up, and we're looking forward into the future with them. Like, we as researchers are going through the panel study with them. So in a sense, we're more like directors of a movie. And so we're looking on to people as time progresses. Alrighty. And so cross-sectional studies, as we said before, are the snapshot. And so we observe a single point in time. And the reason that a lot of findings are usually based off of cross-sectional studies is because it's simple and the least costly way to do research. And there's like less statistical complexity to them too. So we can apply linear components to them and use regressions, which are a simple statistical model that like once you get the hang of it, it's pretty easy to do it in any other cross-sectional study. And so they're typically descriptive or exploratory in nature, unless there's an experimental randomization of sampling added to them. So that's why when you're reading studies that say X and X is most likely to whatever, you want to look and see, okay, what was the design of the study? Is this causal? Was it an experiment? Because then that means that this finding is really, really strong. Or is it cross-sectional and there wasn't a setup where there was randomization? Because then this is more exploratory and I should take the findings not too much like their law, right? Okay. And so there's different types of longitudinal studies. And so this is just a primer. We're going to get more into these specific types because they're often used in quasi-experimental designs, which means when we can't do randomization, sometimes we'll use longitudinal studies to try to make causal arguments. So trend is those that study changes within some general population over time. And so this is what we were talking about in that we're looking over time and it's sort of like a slideshow. Cohort is a more specific population that's changed over time. So in a lot of criminal justice historical studies, cohort studies have been like, okay, we're going to look at this particular class of students that's graduating in this year over time, right? Or we're going to look at people who all started the study when they were 10 and we're going to check in with them after, is panel study. So it's similar to a trend or cohort, but the same set of people are interviewed multiple times throughout the study. Whereas cohort could be people that are connected by being a specific population, but they're not necessarily the same people. And so something that we need to think about is scientific realism. So there's a real, when we're talking about causation, when we're talking about all of these design setups and ways of doing research, there's actually like a science of doing research. And so there's all of this debate about how we should be able to say something causes something. And so theoretical foundation alternative is scientific realism, which sort of bridges the ideographic and nomothetic approaches by seeking to understand how the causal mechanisms operate in specific contexts. And so that's like really high internal validity, really looking at the location of a specific point and doing an intervention that measures this specific situation. And Pawson and Tilley are really big on this. And if you're more into like specific interventions and very specific things, they looked at the design of streets and intersections and tried to make modifications and saw how those modifications developed over time. So it's a bit more relaxed design-wise than doing a research experiment. So it is an alternative, but I wouldn't say you see it a lot too much in criminal justice application, although there are some people who do it. So this is sort of like an alternative to what we see as the gold standard of being able to define crime as experiments and quasi-experimental designs, which will be the next lecture. So hope you enjoyed this primer.